Good morning, crowd. So today's meeting is going to have slightly different format than we usually do. So not just presentation after presentation. We'll have a slot with discussion afterwards. There are two different architectures being proposed, so some alignment needs to be done, number of presentations, and then we'll have SD1 slot, which is again number of presentations and discussion afterwards. I really encourage you to participate. Chairs have pretty good idea that there's work to be done, and given the proprietary way as the one done today, I feel lonely. Absolutely. And thank you for taking notes, Andrew. Do we have anyone on Jabber? Drew? Thank you. So we're about to start, and we start with presentation on apps. Here we go.
Hello. Okay. Hello, everyone. This is Michael from Huawei, and today I want to introduce some progress of the separate BNG. From last IETF meeting, we have do some hard work and our proposed two new documents. One is present the separate BNG's architecture. Another is proposed. Thank you.
Got stuck or couldn't show? Could you try again? Let me know. Oh,
I mean, this, okay, let's work well. Okay, thank you. The first one is present the separate BNG architectures. Another is introduce CUSP's protocol. The first, so my presentation will have two blocks. First is introduce architectures. Another is introduce protocol. And first, I want to mention why we need to propose the architecture of separate BNG. Because in previous IETF meeting, we have already proposed several documents to introduce an interface of the CU separate BNG, but we don't have some document to describe the function and to introduce the relationship of the set of CUSPs related document. So our chairs suggest us to propose some informational document to introduce it. Therefore, we In this meeting, we upload one document. It proposes information and help the reader to understand the relationship between a bunch of CUSP-related documents. And notice that we don't have a strong opinion to standardize this document because it's some information node. And also the architecture of the CU-separate BNG have already been published by BBF-related working group is RP 384. Here we just introduce it and help the reader to understand it. Here this is CUSP's architectural view. You can see the figure, the control plane and user plane within it. There are three interfaces. The first is a real Wikislam interface, which can be used to translate the data package, such as the PPOE, POE, and the related document is shown the following link. Another interface is discuss about the control interface, which the user can, which the control plane can use the interface to send the several service entry. And this can also the user can use interface to report available resource and events to the control plane. There is basically to realize a function of dynamic control plane and dynamic user management. And the ready documents are shown as the following links. It's discussed about some requirements and information module, and some discuss about the separate protocol. The last master interface is discussed about is present the management interface. The user can use this interface to configure the CP and the UP and enables being a separated BNG. And the related link shows the following. So if we use a separated architecture to process some user accessing, it may have the following access. In the left figure, we can see that the right line means users control traffic, and the blue one is the direct traffic. Before the user access, we should first enable the BNG using the NAConfig to configure CP and UPs. And if a user requests accessing, and the user plane can send the data packet to the control plane through the external channel. And the user plane accepts its packet to process the authentication, and you also need to read the user's QS information, service requirement, service level, that it can generate several tables, and then send this table to the to the user plane, such as user information, user IP, and user's QS policy. This will be carried through the CUSP protocol, and to realize dynamic user management and dynamic control plane. So the user plane can forward the data packet with the rules which received from the control plane. Okay, sorry. This is basically talk about CUSP's architecture. And also, last night meeting, our co-author who works for China Mobile have already introduced some implementation test of the CU-separated architecture and the CUSP, and it requires it have a lot of benchmark which requires to high performance and high requirements, which requires to high performance. So that requires a transfer protocol should be lightweight and very high efficiency. And also we should say in last night meeting, the BBF are already sent a liaison to working group and request to process interface standardization group. So in this meeting, we proposed the CUSP protocol, and which should be meet the operator implementation requirements and to design a lightweight protocol to support the seal-separated BNG's control channeling, which can help to achieve the interaction or interwork of different ventures devices. And here, I also noticed that there are some another architecture is discussing about FMC rules of the seal-separated BNG. So here I'd like to discuss more. And now we just show the protocols work, what we have done. And if you have interest in the topic, we can discuss more. Okay. Here is a basic calculation format overview. To meet the requirements of the seal-separated BNG, they need a very simple protocol, lightweight but efficiency. There is a common header and a TLV format, and notice that the TLV format attribute is present in the information module. And if we use a CUSP protocol to process a user dialogue, it may have the following steps. First, we need to set up the session. The UP and the CP can send hello message to perform to process the version declaration. And when the session is set up, the UP will report available resource to the CP, such as available port, available bandwidth, so like this. And the CP have centralized control the BNG's interface through the netconf. And UP then send access, and CP then sends access information to the UP through the CUSP protocol. And then when a user dial up, the user can dial through the Rex line, and CP will send users with CP can raise user process authentication and general rate the user's requirements, service level, and such access. And available resource, then it will generate several entry table and then send to the UP to realize the dynamic user management and dynamic control. And in this IETF meeting, we also do some works in Hexagon. We have verified. We want to verify the validation performance and CUSP, and we have two benchmarks. One is to verify that the control plane can communicate with the user plane was new protocol. Another is to verify that the basic function of the user as a control plane can synchronize management user resource, such as dynamic assigned IP address to UPs, IP address field to UP, and dynamic assigned IP to the access user. If you are interested in this, you can review more detail on the next, or can download the demo video through these links. So. Next up, we would like to discuss more and solicit more comments, and maybe we should discuss more about the architecture, and based on the comments, there we can prepare another version to improve this book. Okay.
One question is regarding hackathon results. Is there any codes that could be shared and results that could be published? What have you achieved?
The architecture was, I think, is informational, is not want to be published or standardized because BBF have already published TR384. So just provide information. And we focus on the protocol design.
So what were you doing during hackathon? You were writing papers or code?
Yeah. It's on it is this draft. We based on this draft to design some code and show it in the hackathon.
Okay.
So, are we taking questions and reflections at this point?
Probably after second presentation.
Okay, I will wait until then.
So we will discuss in the
Yeah.
and then
So we're going to have second presentation CUSP and then have question afterwards.
So same topic, but expanded scope. So requirements and framework do not just account for fixed access on the BNG, but also converged access. So the framework are trying to account for fixed mobile convergence as well. So very briefly, why CUSP on BNG? Two things we see, and just before I actually start there, so the draft is collaboration with some of the operators, and in subsequent versions we have more authors coming as well. So this is based on direct feedback and collaboration with few operators. So then why CUSP on BNG? First, it allows you to separate control and data plane, and it allows for independent placement. It allows for independent scaling. Independent placement means your BNG data plane, for instance, can be more distributed if your CDN caches are distributed. Control plane can be pulled back and centralized. Control plane can be a VNF, and data plane can be either a PNF or VNF based on your use case. The other main driver we see for CUSP is operational simplicity. So it basically, with a centralized control plane, it provides a single point for management and control plane for a cluster of these distributed BNGs. And what it then does is expose a single interface towards the external systems. So to a radius server, AAA server, or a PCRF or an OCS, the whole cluster looks like a single entity. So again, it provides operational simplicity there. The third one, which in our opinion is driving this work, is the most important, is the convergence of the BNG control plane with session management functions in the 4G and 5G packet core. And this is becoming very real. When you look at BNG today, it's largely fixed access, but we also now see use cases emerging for fixed wireless access. Hello? Yeah. So is it better? Okay. Yeah. All right. Okay. So the third one is convergence, where BNG terminates fixed access today by far, but then the emerging case is with fixed wireless as well as hybrid access, and I'll get into that in a bit. Where we see the drivers for fixed wireless, for instance. And then the second is, of course, BBF and 3GPP are working closely to define a converged architecture for 5G, where the fixed access can be integrated or interworked with the 5G core. And there is a working group in BBF that is driving this work and basically working together with 3GPP on that. And then if you look at today EPC and 5G core, CUSP is basically de facto there. So your control plane, user plane separation is baked into the protocol, into the architecture that EPC and 5G core has. So given that now we are talking about BNG with fixed wireless access, which again brings in 3GPP interfaces, CUSP becomes sort of mandatory there. So then what I mean with these different deployment models, you look at the second one here, which is showing the CPE, connected to an MSAN, an access node, connected to a BNG UP. So that's your typical fixed access and Ethernet handoff, .1Q or QNQ. But what you see at the top is fixed wireless access, where either you cannot put fiber, based on your constraints, so you want to use 4G as a replacement, or more recently we have trials with 5G in the millimeter wave bands, 28 gigahertz and higher, where your last mile literally becomes a 5G radio interface to a small cell, which is very distributed. So what that means for the BNG now is that BNG basically terminates a 3GPP signaling S11 or N11 interface to an MME or an EMF, which establishes a tunnel, a GTP tunnel, for instance. And your data plane is again a GTP tunnel, GTPU tunnel, coming from your small cell or your E node B and terminating on the BNG. So it's not only fixed Ethernet layer 2 access, but also tunnel subscriber management on BNG and a tunneled access. And the third, of course, is a combination of two, what we call as hybrid access. Again, this work has been done in BBF to a large extent. And so hybrid access is having both interfaces, either for more bandwidth, where you can't go from copper to fiber, so you want to use spectrum to get augmented or higher bandwidth, but also for resiliency purposes. If your fixed link goes down, you fall back to your, your 4G link, for instance. And in this case, the BNG terminates both the fixed and the mobile connection and treats it as an entity, as a single entity. So in our view, when we look at CUPS, we need to look at all these cases and not just, layer 2 fixed access. So then what is CUPS in terms of functional decomposition? The CUPS is here that we are proposing is purely applicable to the BNG function, where the subscriber management that you typically do, where you terminate your DHCP and PPP from your RGs or CPEs, you authenticate the user, you can talk to a PCRF to dynamically get the subscriber policy, you can do charging, you can do usage reporting. So all that subscriber management that you do, that in the control plane, that now lives in a centralized VNF. And your data plane then could be either physical hardware or could still be a VNF. And then on the data plane element, you still have a local control plane that runs routing and signaling and things like DFD for faster convergence in case you have network failures. So what then does this means is, if you look at the fixed network, typically your signaling is in band, right? You get your DHCP or PPP from the CPE, which in the fixed access case comes on the same VLAN on which your data packet comes in. So your signaling then also hits your UP. So what you need is an in-band signaling channel from the UP to the CP, where you can transparently pass the signaling messages from the CPE that the UP receives onto the CP, which then handles the signaling and authentication and all that. And similarly, the signaling responses going from the centralized CP or control plane towards the CP again goes over this in-band control channel or signaling channel. The second thing you need here is a state control interface. What that means is, once the control plane has authenticated the subscriber, used DHCP, PPP, assigned an address, it then turns around and programs the forwarding state and the traffic management state, SLA management, your cost state, and your usage tracking, for instance, and usage reporting down to the UP. So you need a flexible interface for that, and this will become clear as I go along the presentation, what we see as requirements there. Then the third interface is the management interface, where an operator wants a single point for configuration and control, where they can configure the CP, but also each of the UPs. So all the config and the state information via the management interface. So those are basically, if you net it out, those are your three interfaces between the CP and UP. And again, to the rest of the system on the right, which is your AAA servers or PCRF, this all looks like a single IP, single client, single entity. So very quickly, I won't dwell too much. This is all covered in the draft, but I just wanted to give you a flavor for what the end-to-end call flow looks like. So if you look at the left side, your CPE, I'm just taking DHCP as an example, could have been PPPoE as well. You get your DHCP discover, comes to the UP because signaling is in band. The UP transparently forwards it to the CP. CP then authenticates the user with a AAA server. Once it gets the offer back, it assigns an address. Once all the DORA here, or the DHCP transaction happens and the address has been assigned, the CP then uses the state control interface that I mentioned and basically creates the forwarding state for that IP session on the UP. So that is where I'm showing like as abstract calls here. I'm not defining a protocol yet. So this is a session creation request, which passes in the IP address, attributes for the subscriber, its MAC address, for instance. You may have framed routes. So all those, as well as all the traffic management parameters, your cost profile, your shaping rates, your HQuas hierarchy, that, and also then, usage reporting, if you want time and volume, either threshold based or periodic, so those things as well. And again, this is a request response because you want the other side to acknowledge, even though the transport may be reliable or could be made reliable, but you want application level reliability as well. So that is sort of a representative call flow here. I think I'll skip rest of this, call flows in interest of time, but as an operator wants to change some attribute for the subscriber via COA coming from a AAA server, that results in a session modification request, or you may release the session and that results into session deletion. So these are all session level interactions. You also need a node level interaction where the two entities discover each other and establish a pairing. And once the pairing is being established, they can exchange capabilities with software releases are they running, what is the load and overload information, resource information, etc. And then you need a periodic heartbeat between the two entities for liveness detection. And then lastly, there is also asynchronous notifications from the UP to the CP. So for instance, if you want to retrieve accounting for the subscriber to an external Radius server, you want UP to basically periodically give you the stats that you report or the users that you report. And this could also be credit control more real time. For instance, if you have a GY or a diameter-based credit control on the CP, then the usage based on threshold can also be reported. So very quickly on the protocol itself, the type of information that needs to be passed is what we believe this needs to be very flexible. So here we have proposed is that the CP, when it's creating a session, passes a set of rules or packet detection rules, if you will, which identify the subscriber and possibly the flows of the subscriber, and then specifies an action both for the upstream forwarding access to network and downstream forwarding network to access. So it's very programmable forwarding rules that CP provides to the UP to create forwarding from the CP to the network upstream and downstream. And then also routing information, since routing still lives on the local control plane of the UP. So things like an aggregated prefix out of which you're allocating addresses for the subscribers to announce in routing. Also in DHCP, you hand out a gateway IP address to the end user. And so it needs to tell that to the UP as well, since UP needs to respond to ARPs and pings for the gateway IP. So essentially routing and IP related information, and then finally CUSP and usage related information as well. So very quickly, before I conclude with next steps, what we did is we took a hard look at what the protocol should have in terms of requirements. So I just outlined here, I just go over the key ones. The first major one that we see is it should allow for fixed wireless and hybrid access on the BNG. The protocol shouldn't limit. So it is an operator choice whether they want convergence or not. But the framework and the protocol that you define should allow for it. The second is it must support tunneled and non-tunneled layer 2 and layer 3 access. I mean, again, you have different deployment models. So it needs to cater for both tunneled and non-tunneled layer 2 and layer 3 access. Ideally, the underlying transport should not have head of line blocking. Because again, we are talking about a cluster of UPs, potentially more than 1 million subscribers served by a single CUSP BNG cluster. So you don't want any kind of head of line blocking affecting the performance as you create the state from CP on the UP. We do need application level reliability. So your transport can be made reliable based on retransmissions and sequence numbers, but that just tells you that the protocol message got there. It doesn't tell you whether the operation that the protocol did for instance, instantiate clause, which could fail due to resource management. So you actually need a proper request response at a protocol level as well. Whatever protocol we use goes without saying, it needs to be extensible. So the messages that you support, they should support carrying information elements as TLVs. And these TLVs should be extensible, meaning you can extend a TLV with new information, or you can define new TLVs. And we need to allow vendor-specific extensions as well, as past experience tells us. One key requirement here is that the protocol should limit the chattiness, because again, if you're talking about million plus subscribers in a single BNG cluster, you want to reduce the round trips in order to create the subscriber state from CP to the UP. So that, I think, is a key. When we define the protocol, we need to make sure that it limits the chattiness. The inbound signaling that I talked about before, that channel between the CP and UP should be dynamically set up. So it's not just a tunnel encapsulation or a soft tunnel, but we should, the two entities should be able to control the attributes of that signaling channel. And what I mean there is, for instance, the CP, and I'll get into that a little bit more detail, but CP, for instance, should be exactly indicate to the UP which control messages it wants to receive, or if there's a DOS attack, which messages it should drop or prioritize. But just continuing on the state control interface, so again, the state management must support forwarding state, cross management, and usage tracking, which is both periodic or threshold based. And then, like I said, asynchronous notifications from the UP to the CP for usage. One important thing here is, again, since this system needs to be highly scalable, control plane will typically run in a VNF which can scale out. But what we need to account for also is overload condition on the UPs should be handled gracefully. For instance, we should be able to throttle the messages coming from the CP to the UP on the CP. So some kind of a graceful overload management needs to be there. And finally, liveness detection between CP and UP, so you can enable redundancy there, detect if your peer is down. And lastly, it's a should, but we need to try and optimize the information that is passed between CP and UP where possible.
3 minutes.
Yeah, I'm getting almost there. Okay, let's move on. Inbound signaling channel requirements, again, you can take a look at it, but key is that this needs to be dynamic, where you can control from CP which messages it wants to receive. It can have relative prioritization between the messages, it can drop messages. But the most important one here is it must support transporting both an Ethernet and IP payloads. So Ethernet is normal layer 2 fixed access, but when we look at fixed wireless, when we look at that, your DHCP itself is coming in on a GTP tunnel. So GTP by default carries an IP payload. So you need your signaling channel to transport both Ethernet and IP payloads. And so my last slide then, and I think this is the key and very germane discussion to have, is the protocol selection input. So as we started looking at it, along with few operators that are on the draft, what we've seen is that 3GPP has already defined a protocol for CUPS between gateways. I show that on the right. We call it CUPS protocols. It's defined in TS 29.244. It's between packet gateways, S gateways, and TDFs. So, and this protocol machinery, as you look at it, is really custom built for very large scale state management between CP and UP. All the containers that are used for forwarding state for cross, usage reporting, and forwarding state is very easily and seamlessly applicable to BNG as well. What we need is a few extensions for new information elements or extending existing information elements, mainly because mobile today is layer 3 tunneled, whereas here we also want to, on a BNG, handle layer 2 access. So we have already identified some of the extensions needed, but that will be part of the protocol, depending on how we go. And the protocol itself is called Packet Forwarding Control Protocol. I show the encapsulation on the right-hand side. It is very extensible in terms of TLVs. It has a 32-bit TLV number space, which they have already partitioned as 16 bits 3GPP defined, 16 bits vendor defined. Vendor could be IETF or IANA if we choose to use this for BNG. So finally, what do we want out of this is, at least the proposal here is extend PFCP as defined today for BNG cups. What that allows us is convergence. So it allows you to handle fixed access, fixed wireless access, and hybrid access on the BNG upfront, day one. In future, it can also allow for fixed broadband integration with 5G core, as is being defined in Broadband Forum SD 407. It also, very important, provides us a possibility of a unified control plane. So you can have a single control plane across, fixed UPs versus mobile UPs. So you can have your EPC data plane on a VNF, you can have your BNG data plane on a physical hardware, and you can have, this allows, if you extend PFCP, allows us unified control plane to control both elements. And finally, it provides, if we use PFCP as defined in 3GPP, it is already a scalable and a hardened and a deployed baseline, right? So we don't need to reinvent the wheel here again. So, our suggestion is that if we can, undertake protocol extensions to PFCP for CUSP, BNG, and IETF in the work group. Thank you.
Please stay where you are. Previous presenter, please come up. We'll spend about 10-12 minutes on questions and then try to define next steps. I know the authors have already met and talked, so there's some progress, and requirements in both solutions look pretty similar. So let's start.
Jamal Hadi Salim. So what are you looking for? You said 3G, your last slide. First you said you don't want to reinvent anything. And then you said 3GPP has already designed something. Are you looking for an endorsement? What's the purpose of it?
Yeah, so you do need, so 3GPP has defined a base protocol, which today works for your gateways in EPC. So for BNG, you need some extensions. So you need either some new information element, not a whole lot, but there's some information elements, or you need to change existing elements. So what we are suggesting here is, if we agree that PFCP is the way forward, then those BNG extensions can be done here. So as a proposal.
I mean, the reason I say you don't want to reinvent any wheels, I looked at all your masks and shields that you presented earlier. Have you heard of forces?
Sorry.
Have you heard of forces? I mean, you just listed as if it's cut and pasted from the forces requirements protocol.
No, I didn't cut and paste from anywhere. These are genuine requirements that we see. I mean,
yes, but if you go and look at the requirements RFCs for forces, you'll see 99% of what you just repeated here.
Okay.
TLVs, transport modularity, ability to extend.
yeah. So there are some generic ones, but there are also some specific ones where you want to handle both fixed wireless, and hybrid access.
Those are terminologies. I'm talking about the technology. I mean, you have a data model, you can define fixed or wireless, whatever you want, right? That's how you have extensibility. By data models, you have a fixed protocol that operates on the data models.
Okay, so these are the set of requirements. It's fine if these are
There's
generic.
none here that you're listing that I haven't seen in the process protocol.
Okay, so
Let's
that's
go point taken, and authors will take a look at the process architecture. Michael Lowry. There's no one to answer your questions, I think.
Okay.
Michael, first presenter,
Yeah.
if you would.
Yes. Okay, Dave Allen Erickson, also a longtime attendee of the Broadband Forum. I'd actually say the problem space that frames the solution space is a little bit bigger than just the BNG. We have been looking at fixed mobile convergence, which is mapping wireline access onto the 5G core. Net result of that is one of the operator aspirations or requirements is that the existing legacy kit that today talks to BNGs can be interworked with the 5G core, which implies in a CUPS interface, there would be a staggering amount of opportunity either for engineering reuse or an absurd degree of engineering duplication across the solutions. So what I would suggest is folks at least take a look at what's publicly available related to the FMC work and think about that in this context, because that will tend to frame the solution space and will proceed to save the industry an awful lot of pain. So thank you.
great. Yeah, great point. Yeah.
Wolfgang Beck, Deutsche Telekom.
I think the challenge here is not only to get the tunnels right to the customers, but also the tunnels towards other providers. We have regulatory requirements to provide wholesale. So a customer can use our line, but be terminated on a different router. So you need things like identifying the customer and determine, okay, this flow must be put into a L2TP session to some router or into an MPLS path to some other provider, which stuff. The second challenge I see is keeping the state between the control plane and the user state accurate. And the proposals I've seen so far, that's always a bit short on that. So.
Yeah, so there again, one of the reasons why I say why reinvent the wheel is that 3GPP with this protocol has more or less solved that issue. So this is today deployed on packet gateways. So hopefully we end up leveraging that, and that should give us some comfort. Thanks.
Yeah, George Garagianis, Huawei. I'm also involved in the Broadband Forum, like Bevan also mentioned. Sanji are also working together. But the main point that I have is there are actually two types of work that has been done and is being done in Broadband Forum from the point of view of separating the control plane from the user plane. One of the activities that have been, say, completed on some scale is in DR384 that talks about cloud central office. And there we are actually specified how the BNG could be separated in the control plane and user plane. So from that point of view, there is already an architecture that could be used. You know, if it is to work on an interface between the control plane and the user plane. From the point of view of combining or using the BNG in scenarios where also the fixed mobile convergence is involved, this is in a stage of working, say, ongoing work. And I think, you know, in order to have all the necessary details, and I think it's in line also with what Dave mentioned, we need to work first out what will be the solutions, so what will be the architecture that is needed for such kind of separation, in order to also know what kind of information you will need, you know, to support for the interface between the control plane and user plane. And then we can come to IETF, you know, if we need to standardize this interface.
Yeah, so here is my view, point taken. My view is you get to do this once, and you don't want to end up with two different solution sets. If one can do both fixed and the converged cases, then we need to look at that. That's where we started looking at CUPS from that standpoint. And I see your point that Cloud CO and BBF limited it to fixed access. But I mean, in IETF here, we want to strive towards, you know, a framework that doesn't mandate convergence, but it at least allows convergence. So we need to look at it from that side. Else we'll end up with, you know, two completely different solution sets, and that doesn't help either the vendor or the operator.
Yeah, but just a second. Michael, it's two of you. If you feel there's something to add, please go ahead. It's a dialogue.
For my view, I just focus on some works on the fixed works BNG. So we think the fixed works BNG's architecture is clear, and its process now is required to do some standardization work in IETF. So I think the first step is to design some protocol, design some interface to realize a CU separated fixed architecture. This is my consideration. Okay.
So there are at least two places where architectures have been defined, BBF and 3GPP. Why do we need to reinvent third?
I'm not really have full knowledge about 3GPP's work or mobile works, but I think it should be considered or more discussed about if this two architecture can converge or do. So I think it's need to more discussion, but I'm not sure here, and we need to now realize it.
Okay, thank you.
So I mean, I'm just saying, if we look at PFCP, it can satisfy all the requirements. I mean, what I'm trying to say, we want to start with a protocol baseline that day one, it can support pure layer 2 access if that's what is the priority. But at least, it can be extended to mobile. For instance, if you look at hybrid access today, customers have deployed it. Now, if you have two flavors of cups, you're not going to use one protocol to control a fixed interface and another for the mobile interface. So that's a point where we want protocol selection should be such that it should in future, or even today with hybrid access, allow convergence.
I think there are two gaps now. First, in our realization, in our previous work, we based on the TCP to do this interface. And the 3GPP's work is based on the UDP. So, I think I need to more discuss, and I need to realize, I need to analyze the 3GPP's work. This is the first step. Another is typically as you say, the tables or these entries attributes are quite different. So for fixed networks view, most of the 3GPPs defined attributes cannot be used, and also it can not support the current requirements of the fixed network. So you say maybe it's an extension, and I think
we are not in a semantical discussion right now.
Discussion, but I just at least want to clarify one. So the protocol as defined today is over UDP, but it builds reliability, so no head of line blocking issues, and it also has a protocol level request response. Again, detail, we can do it later, but
Absolutely.
Yeah, what I wanted to also emphasize is that if we want to work on the scenario where fixed access is actually in place, then we can already use an architecture that has been already defined in TR 384. If it is to also involve the fixed mobile convergence, then we need some work in BBF. That needs to be done in BBF. From the point of view of having a CUPS kind of solution that could work for both, this is something that could be discussed, but it needs a lot of time. So maybe we could start first working on what is possible, and then extending that work towards the fixed mobile convergence section.
Point taken. Thank you. Second mic is Andrew. Andrew.
Hi, Andrew Dogan on Nokia. So I want to kind of second Dave's comment. This is an opportunity to do something right, but also this is a danger to reinvent a lot of stuff that has been solved by many people already. CUPS is not new in some environment. We have to make sure that what we come up with is not an additional complexity, because the industry is moving with 5G to allow not only single fix, not only mobile, but also combination. If we think we can maintain multiple solutions, that will be very tricky and very difficult for operators to run with. If we think, going to the first presenter, that we can replace a lot of existing 4G, and as it moves on CUPS control plane with a new totally protocol, I think we're kidding ourselves. So taking what it is, making it better, working with BBF, working with 3GPP to get the architectures together, definitely what we need to do, no question.
Okay. Please go.
Dinchen from Huawei. I just want to second David's opinion, and very strongly suggest you to leverage and reference what being done at the BBF, and also the collaborate with the current work in the BBF, because there's a lot BBF for many years produced a very popular specification on the BNG, and some they consider they are Bibles in the industry. So, and especially for the architecture and the nodal requirements, there's a lot of work being done and published by BBF already. So that's the right place to work on. And of course, some of the protocol extensions, whatever, have to be done here.
Correct.
And for example, I noticed that for the first parameter, the draft, I forgot which one, referenced the TR 384, right? That's the cloud central office. So I noticed that that TR just recently published that did mention the CUSP, right? So, but the second parameter, you mentioned the WT 378, and that is a nodal requirement for the hybrid access. But I just look at it over yesterday, and that didn't mention anything about the CUSP. So if you talk about the architecture of the CUSP, then my recommendation is to collaborate with the BBF.
Yeah, so just
there's an ongoing work also, for example, the 5G transport, where we talk about the CUSP.
A quick response to that. So BBF does not deal with protocols. BBF defines frameworks and architectures, and Cloud CO, at the time when they were looking at that, they did not take convergence into account. So it's a procedural thing, but we should not let that limit, what customers are telling us and what we need.
Yeah, that may be a good point, but what I'm trying to say is the BNG for many years being the architecture nodal requirement being specified by the BBF.
Yeah, so
and then it's an industry standard. And then anything related to the BNG, I think it should be done in one place. And of course, as we agree, the protocol extension have to be done here.
Correct.
So that's my recommendation.
So BBF is aware of this work. We've got liaison from BBF to routing working group IETF here, and we expect cooperation with both SDRs.
Okay.
So, Evangelos Chaloplidis, Mojatok Networks. So, yeah, I agree with the two commenters before that there is already work that has solved a lot of these issues. But my main comment is that I think that there is a terminology skew. It looks to me that what you're doing is management plane to forwarding plane instead of control plane. Everything, there was a figure before that in the control plane, everything you had was management, right? So I understand that this work has been done also in the 3GPP. So there is an RFC 7426 by the IETF about terminology in the SDN layers and planes. So it may make sense if you can, if not align, but provide a kind of map between what you're doing and the terminology that exists in the IETF world.
Okay.
Very good comment, thank you.
Yeah, Wim Hendricks from Nokia. So yeah, I think we have a unique opportunity here to solve the fixed mobile convergence use case. So I think we are rushing into only doing fixed BNG is, I think, not the right way forward. But I think the message which I see here is definitely that in BBF there is a gap right now because they have defined CUSP for BNG in Cloud CO, but they haven't defined CUSP in all the use cases which a BNG could work in. And maybe we should give a response towards the liaison request which we got from BBF to say, okay, why don't you do and work on the framework to allow CUSP to do both fixed mobile and hybrid access. And then once that architecture is in place, come back here and we would be doing the protocol extensions. I think that would be, in my view, the best way forward because it seems we have not in BBF a full view on all the requirements which are required in this space. And as a result, I think it's best that work happens there. And then once that is more or less in a good state, is that the exact protocol extension and protocol to be used would be done here and would be extended here. That would be my suggestion.
Praveen Mohan, Nokia. So I think the question of choice of protocol, if you look at it, the 3GPP has already gone through all the discussion about whether to use TCP or UDP. If you look at the user plane requirements in general of BNG and mobile, you will see that they're actually one and the same. And if you look at the constructs, like what Sanjay had a slide about, where you were identifying a session in terms of policy enforcement, in terms of collecting the statistics, all that work is already done. Now, there was also one question about forces, why we should not use the forces. But if you look at the actual PFCP protocol, it has got all the integration in terms of what you need on the GUI interface, in terms of your offline interfaces. And so there is no need to really repeat all that work or discussion out here. So what we can do is we can use that, the work, and leverage, use that as a
Jamal, we're out of time, sorry. Take it to the list, please. So we are done with questions. So as next steps, I see definitely need for an interim, so to align all the stakeholders and discuss as well alignment, because requirements, again, look pretty much the same, it's just how you're trying to do it's quite different. Talking to BBF is another step we're going to take, and hopefully Dave and Georges and other people involved could help with that. And I would really like our authors to propose to talk to each other and see how we can find points that are common across to and start working towards common solution. Thank you so much. Janssen?
It's not my size.
Oh, that's not yours.
Thank you. Thank you, Jeff. Good morning, everyone. My name is Shen Yan from Huawei, and this is a new draft here. And in this document, we try to analyze some constraints of SRA 6 in some scenarios, and then try to make some extensions, improvements based on that. If possible and necessary, we try to provide a new encapsulation scheme for the current protocols. So the first constraint is segment consumptions. We know that the SID of SRA 6 is locator and function coupled design. So once the packet needs to pass through a router, there will be an IPv6 item in the header. So here is a simple example here. The PE1 sends a flow to PE2 by the path from P1, P2, 3, 4, 5, and each router on this path is required to execute the function of the limit. So in this case, in this example, the packet should be like the right side, and the total cost before the original IP packet should be 158 bytes. So this value is too large because the average packet size on the internet is less than 500 bytes. And in these cases, it will occupy more than 30%. The long header, we don't like it. What's more, the long header will cause another problems is low efficiency. The current network processor normally will read less than 100 bytes at one time. So if the header is too long, we need more time slot to process. So one of the potential solution is to decouple the instruction and locator in the data packet. And then we use a globalized instruction instead of the localized one. And also we want to introduce some new schemes such as the flow ID to indicate the path. So as shown in the figure, to limit the packet rate for the specific flow, the packet sent from P1 to P2 should carry two globalized instructions. The function 1 has a schematic of shortest path, maybe forwarding the packet according to the P2's addresses. And the function 2 has the schematic of limit the packet rate based on the flow ID and the given max PPS. So here we can compress or use the shorter instruction code or shorter file to
express the function, the flow ID, and the PPS. And we try to reduce the header length less than 50 bytes here, which is much shorter than the current design. And the second constraint is the multicast. So in the current ISA-v6 design, if we want to implement multicast, the packet must be replicated as the ingress PE because the locator is contained in the ISID, and then the egress PE use different ISID for the same VPNs. So here we have an example. The CE12345 construct a blue VPN, and CE1 sent a broadcast frame to all the other CEs. Because of the localized semantic, the different routers use different ISID for the same instruction metadata, and therefore the multicast packet must be replicated as the P1 instead of any P routers in the network. So we can see there's 4 different packets in P1. Actually, it is unicast, but not multicast. So if we can decouple the locator and function, meanwhile, all the P routers perform same operations according to the uniform instruction suite, all the multicast packet will be same in the egress, so that the packet could be replicated at any P routers in the network. Such as we show in the figure, after receiving a broadcast Ethernet frame from CE1, the ingress node PE1 only need to encapsulate the frame into a single one packet, and the packet should carry 2 globalized instructions. The first one, function 1, has a semantic of maybe forward and replicates the packet according to the multicast address of group P2 to P5. And the second function 2 has a semantic of if there's no next hop, strip the header and look up the VRF of the VPN and then forward it. So in this case, each transit node in the network forwards and replicate the packets based on the multicast addresses. And the egress nodes perform the corresponding VPN actions. So we can see it here, the P1 can only use one same packet to multicast. So here we have a short summary of our main sort, two main points. The first one is we want to decouple and reuse all the data contained in the header. And then we want to use globalized instructions in the header. So we try to compress the left longer SRv6 header into the right one, the shorter one. So in this talk, we only provide 2 cases analysis, and in the next version, there will be more. One of the upcoming is the application and security. So, because of the coupling, when the users or the applications want to program the routers, they must know all the locators or topology information of the ISP's network. This will potentially introduce some security risk. We don't like it, so I hope our proposal can deal with these problems. And the next step, we will continue to involve the draft, and we plan to have a demo in 103 or 104, and any discussion and feedback are welcome. Thank you.
Any questions? Thanks. And probably you should also try to present it in spring next time, because you're proposing. Sorry, go ahead.
Martin Vigo, Routing AD. I strongly suggest you discuss that in spring and possibly in 6 months as well.
Okay, thank you.
Gilberto? Next presenter, please. Thank you. Next presenter.
Good morning, everyone. I'm Zibo Hu from Huawei. And now I will introduce network automatic optimization.
It looks like PowerPoint disagrees with us, so just let me know. I'll change the slide.
Next page. We know PCE centralized calculation can solve network congestion because it has a global view. It can easily change the path, avoid congestion link. But how can we do that in the distributed computer scenario? Using the dual bandwidth as IGP metric to calculation shortest path may be a solution, solving the link congestion problem. But it's difficult to converge to a steady state using this way. This document tries to automatically optimize the path in the distributed computer scenario to solve the link congestion problem. This page, I will introduce how we can do this. When the device detects the link is congestion, it can select one or several flows to change the path of the flow using log policy. The device automatically generates ACL rules to distinguish in the flow which is select from other. The ACL rules can be defined by IP5 tuple, DHCP, IP address, source address, and add up destination IP address, and so on. The more detailed information about the ACL rules, I will add up in the later version. IGP advances a new sub-TLV enable TLV to carry the adjust metric and ACL rule. This sub-TLV we will add some information about adjust metric. The adjust metric is used to increase the link metric to move the flow away from the link. The ACL rules is to use to define the flows. Yeah. The other nodes in the network receive the sub-TLV, use the adjust metric value of the link to calculate the IGP short path. The device downloads the ACL policy to the following table. The next hop using the result calculation according to the adjust metric. If the bandwidth of the link bandwidth is less than a certain threshold, the device deletes sub-TLV and traffic is restored to the organized state. We will add a new sub-TLV for neighbor TLV. This sub-TLV will define adjust metric and ACL rules sub-TLV. Benefits. This way can be used to solve the network congestion problem without controller or traffic engine. It is suitable for IP forwarding, SR, and other distributed calculation path scenarios. Welcome comments on my list. Any comments?
Yeah, hi, Jacob Hodge, Cisco Systems. What's going to happen here is that the traffic moves, and then you're going to congest the other link, and then you're going to move back again, and you're just going to be flapping the traffic back and forth, flap, 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 flap. This kind of proposal comes fairly frequently, and the trouble is that before you bring such proposals, you should see what's happened before, or propose it to your senior members before coming with these things?
I'm sorry.
What Jacob meant is that if you start moving traffic, you might congest other link, and then you'll move back and congest initial link, and then you will move to another interface again.
So this is a control theory problem. Can you analyze that?
Can we discuss it on my list?
Can you bring this proposal to your senior members and then discuss it with them before bringing it again? Because they should know.
I have a comment too. You mentioned that you are going to look into flow information, not only on rate peak. That means that you have to keep states per flow rather than doing destination-based routing. It has significant implications on the way you do forwarding, so you might want to think about it. So,
I just want to, if the link is congestion, we define SEO rules to adjust this rule flows path away from the link.
How do you know which flow to move?
We can detect because if
That's okay, you can just keep talking.
Okay. If we have two flows, one flow is 80%, and one flow is 20%. We can traffic counting. So we can decide we change the flow B, which is 20% flow to away from the link.
Understood. Thank you. Just bear in mind, it's much more complicated than what you say. Dim, do you want to?
Dan Bogdanovich, if you go a few slides back, any of those topology flows that you have there, one more. For example, this one, and you want to move flow from A to B on any of the nodes. How do you know what is the link state between, if you go to the furthest right, the bottom, what is that link capacity, and that when you move the flow B to that link, that you will not oversubscribe that link?
We can according to traffic studies.
I would really like you to discuss this on the list. There are significant technical limitations to your solutions. Okay?
Okay.
Thank you. Dave.
Okay, good morning. Dave Allen, not wearing the broadband forum hat. In other words, in the Monty Python terms, and now for something completely different. What I want to talk about today is a draft framework for computed multicast applied to SR MPLS, co-authored with Jeff and Ian Duncan. Next slide, please. Okay.
It should be working for you.
Yes, I have the power. Okay, so what the draft is about is using computation for the routing of MPLS segments, or for multicast segments in an MPLS-based SR network, and how tunneling using node SIDs can be used as part of multicast tree construction. And we can consider this both from a distributed or a centralized control model. For those of you familiar with 802.1AQ shortest path bridging, it would be the exemplar of how aspects of a distributed model could work. What the draft does, it describes the terminology, the overall approach, how to construct either loose or explicitly routed multicast trees, provides an algorithm for the tree construction, for the computation aspects, and goes into some of the FIB installation procedures. The key motivation here is to reduce state. Multicast state can rapidly dwarf unicast state if you have lots of multicast trees. And to give you a sense of this, it's right now with flat multicast, it is in proportion to network diameter. Now, if we can eliminate all of the transit nodes from having to install state, then the problem typically will simplify down to 2 times the number of leaves per tree as the absolute worst case is the amount of state that needs to be installed in the overall network. And I've got an example of this a little later in the presentation. The second motivation is to try and leverage the MPLS data plane and segment routing as much as possible. So we're looking to use the SR-MPLS data plane in ways that, for example, PIM or MLDP-like approaches could not, and to offer a multicast solution in scenarios where beer was not technically or economically feasible. For example, on existing kit, or with the sort of cheaper class of switching chips that are used in data centers, for example. So if there was sort of a continuum of solutions for multicast where beer is completely stateless, and for example, we considered PIM or MLDP as stateful as possible, this would fit somewhere in between there. It's significantly less state involved in the data plane than there is for PIM or MLDP, but it doesn't achieve the sort of the stateless nirvana that beer does. So the draft describes the architecture where the multicast trees are constructed as the combination of roots, leaves, and replication points interconnected with tunnels. And the routing of the tree is determined based on information in the IGP. We do all the multicast registrations in the IGP, and therefore that, when combined with the topology information, provides a node with sufficient information to determine its role in a tree. Now, this gives you a whole bunch of benefits. You have a minimum of messaging to converge the network, because a topology change is the only additional piece of information that any node needs to determine its role in a multicast tree. As I mentioned, we have substantially reduced data plane state. That also means things tend to speed up because there's less stuff that needs to be pushed into the fib on a topology change. It reduces the bandwidth requirements versus straight IGP-derived trees. I will get into the reason for that in a moment. And finally, unicast convergence will provide recovery for most failures if you consider a reasonable portion of the trees are going to be sparse state, because the actual change will not affect which nodes have to have state in them for the multicast component. So I've got an example tree here to give you an idea of what's going on. I've got a root, I've got 4 leaves, and the computed solution determined that there was 2 additional replication points required to serve that. And not all the replication points or the leaves were immediately adjacent, so the algorithm permitted us to interconnect those using the node SIDs. So the net result of this is that in the network, only 2 additional nodes out of a potential 5 needed to install state to fully service the tree. So for example, node 16, 0 and 9 and 14 did not need to do anything as part of the actual process of serving the tree. So that right there is about a 60% reduction in the amount of state in the core amongst the nodes that themselves had no particular interest in the multicast tree. Now, this means there's some required tree attributes, or shall we say desirable attributes. If we're going to use tunnels, what we want is a minimum cost or near minimum cost multicast tree in order to be ECMP friendly. And the goal here is to avoid any sort of requirement for logical multicast in any link. If you think of something like head-end replication, where I may have like 3 interfaces off my node and 50 leaves, I'm sending 50 copies on the 3 interfaces. What I'm trying to get to, or what we're trying to get to in this draft, is the idea that worst case, I'd only ever send 1 copy on any interface. There is an ECMP-friendly tree construction algorithm in the draft, and serendipitously, it also is a source of bandwidth, the bandwidth improvements that I mentioned, because what it tends to do is enforce choices that push the replication points closer to the leaves. And what that does is that reduces the overall amount of bandwidth required for any given tree. Now, we can also have the notion of loose and explicitly routed trees. A loose tree is composed of a single multicast segment with a SID associated with it, where only the root and the leaves have been specified, and the actual routing of it is determined directly from the topology. An explicitly routed tree is composed of a concatenation of loose segments, where the roots The interconnect points or waypoints and the leaves have all been specified. The routing of the individual segments is still computed, and with this mechanism, we can specify the pinned aspects of the routing of a multicast distribution tree to like any arbitrary level of granularity. Now, if you got a sense of deja vu, and I see lots of faces here that were there, this was last presented in IETF 97. At the time, it looked like the consumable multicast solutions, or the comestible, was going to sort of take over the world. It's now a significant amount of time later, and that hasn't really happened, and it doesn't look like it's going to happen for the lower-end devices. So it turns out one of the things I did not realize back then was there actually was a community of interest that was interested in this solution, and hence I had lots of motivation to bring it back. The current draft updates the terminology to align with the current state of SR-MPLS. It has some editorial improvements for readability. It's added some motivations. There are some improvements in the algorithm description. Going through and double checking it, when we went to bring the draft back, we found there were some things that could be expressed better and with greater clarity. And it also offers some thoughts on SR controller operation. Now, I'm looking to collect feedback for the draft, which is one of the reasons I'm presenting it here. We do have some updates to the draft planned, some improvements to the FIB installation procedures. Some concerns have been expressed to me that this doesn't quite fit with the current state of MPLS friendliness, and I want to double check that. I don't think that's actually an issue. We will bring forward future drafts with the required IGP extensions and for interworking with existing mechanisms, and we're going to be pursuing standards track. Given that the segment routing group currently does not have multicast in its charter, the current understanding amongst the leadership is that we will be taking this forward in PIM, and we are seeking PIM working group adoption. So I don't know if I've got any time for questions or comments.
Yes, you do. Any questions?
Tony P. Juniper. In the crux, you're suggesting to marry the whole thing to segment routing now, right? So this is undeployable without segment routing deployment.
Sorry, say that again?
This is now exclusively tied to SR. This is only deployable when you have SR, correct?
Actually, the question came up in PIM, and upon reflection, given that MPLS has been made friendlier, or SR has been made friendlier to MPLS, you could also envision how this could work in an LDP network. So the key thing it takes advantage of is the a priori mesh of tunnels between the various nodes. So there is a possibility to do an MPLS version as well. SRv6 is a bit more questionable because it's doing pushes and pops at transit nodes.
Yeah, okay. The rest is like, who has really the charter to muck with all these technologies in one pile? But that's beside the point. Thanks.
Yeah, okay. Lola?
So, Laura Anderson, I must apologize. I didn't follow too closely. I just listened and didn't take any notes. But you're kind of relying on MPLS or the MPLS friendliness, creating the MPLS friendliness. Would you consider actually writing mail and send to the MPLS working group and actually introduce this so we can get the feedback from the MPLS working group?
I would be very happy to, and I probably should have planned in advance for that, so thank you for keeping me honest.
I'm Jinrong from Huawei. I do think this is a very strong algorithm, but it is not very good to combine to considering the data plane. So my comment is like this: you divide this draft into two parts. One is the algorithm, and the left into some separate drafts, such as the FC 7811 and 7812, like this.
Okay, so you believe this document should be partitioned into a number of items?
Thank you. Thank you.
Okay.
Dave, so Tony P again, only one question. Now I know I'm confused. So are there elements of PIM signaling now in this proposal?
No. It will interwork with PIM quite nicely, but it does not use PIM.
So why PIM working group? Okay.
It's simply because PIM is all multicast, not just the protocol itself.
So probably you missed PIM is not dealing with PIM only, it's dealing with all the multicast. Does this? Thanks, Dave.
Okay.
So, and to emphasize the point, this presentation has been made for your information. It's not going to be as part of writing working group working, that is going to be in PIM if Chair so wishes. Linda?
And if anyone has any questions or reflections, feel free to contact me or post on the PIM list or wherever. Thank you.
Good morning. This is Linda Dunbar from Huawei, and today I'm going to talk a little bit about SD-WAN. And SD-WAN has been in the market for last 5-6 years.
If I may interrupt you for a second, sorry.
What is it?
I'll interrupt you for 20 seconds. So we are about to start SD-WAN part of this meeting. And so the idea is that we will help other people already started this work, being ONOC, being NEF perhaps, to provide our expertise and know-how in protocols. So, there's no interoperability today in SD-WAN solution at any level. If you look at classical picture, we've got management, control, and data planes. On management plane, service representation, we know how to build service models. I think we could definitely help building service representation. Control plane, we have the place. Now, a lot of solutions use IETF protocols, being BGP, being next hop resolution protocols, so we could definitely work on this. Data plane, I'm not convinced yet, maybe sometime in the future. Please go ahead.
Thank you for the introduction. So SD-WAN is a pretty big topic, and everybody in the industry have different interpretations. So try to avoid boiling the ocean, we have a new name. In IETF, we call net to cloud, network to cloud, just to focus the control plane part of the specific use cases of SD-WAN. One thing is for SD-WAN, like we've been lots of buzzwords, and there's lots of conferences, and in NEF, in ONUG, they all have projects on SD-WAN. But come to IETF, most people start with the question is, we don't need any protocol extension. So today, my talk is really about to stimulate some of the discussions. We point out some of the gaps, and those are just starting point. And some other companies may have different needs and may identify different need for the protocol extension. So this is really just the beginning. So let's start with the use cases. So traditionally, I call them classic SD-WAN. Basically, you have CPE devices, maybe placed anywhere, and you have existing L3 VPN, interconnect them, or L2 VPN. And now we want to aggregate some other path, like internet paths, to make the bandwidth more flexible and to expand them on demand. So looking at this picture, it looks pretty simple. Like you have 2 points, interconnect by MPLS VPN and internet. But the truth is actually it's much more than that, right? So when you have a network like with hundreds of CPEs, managing them can be troublesome. It's almost bring back to the frame relay days. The mesh interconnection can be very complicated among the CPEs. So that's probably one of the reasons, even though enterprises started with wanting SD-WAN, but in the end, most of them are pursuing managed services, meaning service provider manage the SD-WAN for them. We call that CPE-based VPN, or integrating with SD-WAN. Another use case is really that enterprises today is under pressure to transition to the digital world. And with that, they have to be able to enable their applications in places where their clients need. They call application portability and data portability. And now there are regulatory needs, and certain data can only be stored certain places. That's basically driving the desire of using the cloud data center. So with cloud data center, with lots of those applications being transit, meaning not permanent enough to build up the physical infrastructure to those locations. So there will be lots of demand, actually there are lots of demands requiring to be able to interconnect those floating points into your existing VPN. See, for example, the enterprise today already have the VPN interconnecting their branch offices. Suddenly they need a few branch offices to be instantiated in a cloud data center in another country, in another place. So SD-WAN becomes a very, very convenient way to be able to bring those CPEs to their branch offices. But if you just talk about plain simple SD-WAN, like in this example, you have E1, E2, both carry different applications. Just simple SD-WAN interconnect them through any kind of path, like internet path. When they are close together, like in one campus, that's fine. But when they are across the country, continent, the performance can be unpredictable. So it's desirable to be able to finding the closest PE for those endpoints, so that those endpoints can hop onto the enterprise existing VPN as quickly as possible. So to minimize the last mile, basically maybe it's LTE or maybe it's a third party public internet. So that's the second use case. And the question is really what is lacking in IETF, right? We have developed many protocols, and we definitely can kind of put them together into use. So during our deployment, we find out some of the useful part and some of the missing part. Like for example, 5512, we find is really useful. IFC 5512 define the specific SAFE for tunnel. So we can utilize that to establish tunnels among CPEs, and specifically for tunnels. But unfortunately, that obviously being obsoleted with a new tunnel in cap proposal. So that proposal, tunnel in cap, which is I think is going through IDR last call already, we find it has some trouble issues when we want to use them to deploy SD-WAN. So for one, this tunnel in cap draft require all the tunnel advertisement to be attached to route. And for SD-WAN, those tunnels among different sites, those tunnels have to be created without the routes being attached to them. And then we have people suggest to us, let's just use a fake route, just like a whatever fake route to create a tunnel. That's fine if it's just one tunnel. But the problem we face is for each CPE, we may have multiple ports to the wide area network, to the WAN ports, like we may have 3 or 4. And if we have 300 nodes or 500 nodes, and pretty soon you'll find out there will be many tunnels needed. And just to managing those fake addresses can be troublesome. Is require lots of work during deployment. And especially in SD-WAN, it is expected zero-touch provisioning. You put the box in there, it get up by itself without any touching of the device. So managing those so many fake addresses can be a problem for us for just general SD-WAN deployment. So let's assume this 5512 SAFE are still there. That's what we want. If that is there, we can easily extend that to add needed attributes for passing the SD-WAN needed information. For example, we would like to have controller dictated IPsec peer authentication instead of peer-to-peer. You have questions?
Lou Berger. So did you look at the complexity implicit in the tunneling cap SAFE of the need for doing a recursive lookup inside BGP in order to support it?
I'm sorry, I don't quite.
So if you do the 5512 NCAP SAFE versus using the NCAP attribute, which is what you have in the draft, which deprecates the NCAP SAFE. If you use the NCAP SAFE, every route that uses a tunnel, when you receive the routes, you then have to resolve it against the regular update with the actual prefixes that map into a tunnel, that you then have to locate the tunnel and resolve into that.
Yes,
and
yes.
It's pretty complex.
It's complex too?
Yeah, and you're proposing that we go back to that? Is that correct?
We're thinking we need a specific SAFE, not necessarily going back to 5512. We may create IPsec SAFE, something like be able to create the tunnels among the CPEs ahead of time, so the controller can push down the policies on what kind of prefix going to what tunnels.
Yeah, so that's what 5512 plus 5566, I think, did.
Yeah.
And to my knowledge, we're the only ones who ever implemented it. And it's actually out there in, I think, in open source code. People care about it. It was really hairy stuff to do. And
really hairy?
It was pretty complex to get right.
Okay.
And you had a fair amount, sorry about that, my apologies. You had a fair amount of processing overhead in order to resolve the routes. And so, and then there was all these boundary cases of which one there's timing issues of which one you receive first. And then you end up building nice long lists of routes to be resolved.
Okay.
And it certainly works. We have a working implementation of that. But it's really complex to the point where we said, we really don't like this. We prefer what's in the draft to always carry around the tunnel entry together with the route advertisements. And while it means you have more advertisements, the processing in the code's a lot simpler. So in terms of what you're talking about, I think it is completely viable to make it work. We did it. If you want the code, it's in open source, but I'm not sure it's worth it.
Oh, okay, that's so glad to hear. Right? The purpose of today's discussion is really to bring up the issues we want to hear from other vendors. And 5512 is too complicated. We shouldn't use it. That's fine. And
it's not the issue of 5512 being complicated. It's actually really straightforward in terms of to define. This is one of the cases where when you separate out the theoretical definition from the actual implementation, you miss complexity. The 5512 definition is really straightforward. 5566 is also really straightforward.
Okay.
It's the code that gets really complex.
Okay.
It's the amount of memory and processing that you have to do in the corner cases.
Okay.
And whether you use 5512 or define a new SAFE just for IPsec or for whatever your particular tunnel type, it's not going to change that.
Okay. Okay. So you're saying that this tunnel in cap approach is much simpler. So
the tunnel in cap attribute that you carry with the actual route eliminates that resolution, that level of indirection. It's a lot simpler to implement and to maintain. The trade-off here is you have a lot more updates.
Okay.
So it is certainly an optimization trade-off.
Okay.
Do you want more verbose updates and simpler code and really less memory, actually, it turns out.
Okay.
Do you want that?
Okay.
Or do you want to optimize, I'm sorry, I lost which way. One is more verbose than the wire, the other is
Okay.
more compact and harder and more complex code.
Okay.
It's a decision, so we had the complexity and the flexibility in 5512, and based on implementation experience, we said it's not worth it.
Okay.
So if you want to go back on that, we have the technical specification. The question is it the right choice?
Okay, thank you very much. Yeah.
Jeff has, so this is largely building on what Lou had actually said. 5512 mostly was not implemented because it was decoupled, and that meant that your route resolution code needed to be able to deal with the fact that the information not only is tied to IGP-like existence, but whether or not you have tunnel mappings that's being received across the additional SAFI. The NCAPS draft fixed a lot of that. Where we are seeing this used in our own internal implementation right now is for the SRTE policy draft, which I have to agree with Lou. The majority of the implementation complexity in that is that it massively overloads the route resolver to do all of this stuff. And it does work. It's excruciatingly painful. I would recommend looking at other technologies, rather than going down this path for what you're doing.
Okay, so just make sure I understand. You're saying that SRTE SAFI is also troublesome? Did I hear that correctly?
This is the SRTE-policy draft
Right.
where you're using BGP to signal, attachments for SRTE routes.
Okay.
So it's a couple of our friends with the large data centers are the ones that are driving this, and the draft history itself will show that even they're not necessarily agreeing on how some of these things should work.
Oh, thank you so much. So, well, the purpose of bringing this here is just to get more input on this. With the tunneling cap, we also encounter issues as well. So hopefully this is the right place, IETF, be able to find a better solution, a perfect solution for this. So next IETF will bring in, maybe get all interesting parties together and be able to find some kind of solutions or draft.
So a side comment, you've been having this discussion with your email with some others. If you would provide more concise view of what you're trying to achieve, you might get much better advice rather than asking, should I use some CUSP versus new SAFI? Or, people don't see the end picture, and you might get different answers based on, the slides people understand out of the question.
Yeah. Actually, I have a few slides showing how to use them. So maybe whoever interested, we should get together and then talk about it. And actually, the work actually spread it into many different places. We saw this draft, the CQL3 VPN, we find out, hey, that's really what we need. This is really about particular CP-PE being remotely located in some place, like maybe in a hotel somewhere. They need to securely interconnect that CPE to the existing VPN. That's actually very useful for the SD-WAN environment we are looking at. But the problem, after talking to the authors about the intent of this document, they are really looking at maybe only one CPE being out there. So they're talking about everything is hand provisioned, and you set up the IPsec contribution, the parameters, and you have keys pre-installed in those places. And so those CPE being placed like in hotel here, for example, they can connect to their existing L3 VPN, securely establishing the IPsec tunnel. So that one put limitation on the SD-WAN deployment, because SD-WAN, you're talking about not just one CPE, you may talk about hundreds of them, and it's not scalable to be able to hand provision all the contribution attributes before you deploy them. They're expected to come out right away. So that's the discrepancy between this particular draft and what we need for SD-WAN. And
Linda,
also-
5 minutes.
Oh, I only have 5 minutes? Why thought you said give me lots of time. So.
You are over a lot of time.
Okay, you said. Okay, so I'm going to talk very fast. Okay, so to try to stimulate some discussions. Like say some protocols that extension we would like to have, and this is really for the discussion. I was hoping to have some more like a discussion on this. Basically, if you're talking about large-scale SD-WAN deployment, and to do this point-to-point tunnel doesn't scale well, right? So just like frame relay, you have too many tunnels to manage. So usually we break them into clusters. Each cluster may have some CPEs, and they have the route reflector. The route reflectors are interconnected together. And second part is for zero-touch provisioning. Although CPEs powered up, they will be able to have established TLS session with the controller, and then the BGP will be able to distribute needed information. Second is for the SD-WAN deployment, the IPsec, entire IPsec implementation, we need to simplify that, because IPsec is assuming all the CPEs, all the end nodes, they are traversing through untrusted domain. But in this particular deployment we have is all the CPEs actually will establish the secure channel to the controller first before they can get any kind of configuration done, right? So they already have a secure channel between themselves and the route reflector. And the route reflector among themselves has secure channel. So for the IPsec, there's a peer authentication between the end nodes. This actually can be centralized at the controller. So CPE doesn't need to authenticate his peers. He can request to the controller, I need to talk to Adrian, for example, and the controller will decide whether I can talk to him or not, and be able to tell me what kind of capability he has. His 64 bits encoding on 128. So they be able to sort that, and then be able to pass down the public key to the both part, and then both part can compute their security association keys. So that's actually, we discussed this in IETF on the controller distribute those keys. We're hoping, since all those CPEs are managed by BGP already, we can extend the BGP attributes, maybe creating a new tunnel type to carry the information. And for the BGP, especially like when we have cluster of CPEs, sometimes the route change, you would like the controller to decide, hey, I want to reroute this to, for example, from Montreal to Dallas, I want to reroute them to New York. I don't really care which CPE in New York actually take over the traffic. But there's sometimes you will need to be able to specify which tunnel to use. So, with that, we'll need not only endpoint, we need the coloring for different traffic. We also need ways to distinguish different sites. For the BGP distribution, the controller has to be able to pass down the public keys to each end node, and you need to do authentication. And so basically, we are changing the IPsec in a way. Instead of everything goes through public internet, the IPsec control information, the IKey, is actually goes through the secure connection, basically from CPE to his route reflector or local controller, and local controller to local controller, and to the other CPEs. And the data plane, they can do encryption, and they can go through internet, and they can go through different paths. So that's another change required by the SD-WAN.
So BGP work obviously needs to be done. IDR not here.
I understand, because you said this group is that actually a group can talk about work in different places. So there's L3 VPN components, there's IDR components, there's IPsec components. So different components for SD-WAN deployment. That's why we bring the work here, and hopefully we can have some discussions, just like Spring, right? The work is dispatched to different groups.
Sure.
And here we're talking about how we put everything together.
Please finish up, okay?
Okay, yes, but actually, that's it. That's my last slide, I think. Oh, for the tunneling cap, we think we need a new type, be able to represent like IPsec distribution, or maybe we want to distribute the net, right? Instead of having the CP to resolve themselves, the public and private addresses, having the controller dispose them, the mapping giving to them. So here, just lack of a better word, I said SD1, but maybe a much better word can be used to represent this kind of tunnel type. And also that for a tunnel advertisement, we need a BGP to be able to group them together and be able to only advertise to the peers within same tenant, not cross-tenant. That's it.
Thanks, Linda. So we'll be having discussion after second presentation. We're not finishing.
Oh, okay.
So you know.
Right.
Steve? Thank you.
Thanks, Jeff. My name is Steve Wood. I work at Cisco in the Enterprise Networks Group on SD-WAN. And I'm also the co-chair of the ONA Open SD-WAN Exchange Working Group. And the purpose of the ONA Open SD-WAN Exchange Group was to basically start the process of making SD-WANs open. So open is kind of the first letter in ONUG. And one thing that we noted as we were moving along on the journey of SD-WAN is that there really wasn't openness between the SD-WANs themselves. And so we created the Open SD-WAN Exchange as an open framework to create an open framework to really allow one vendor SD-WAN to federate and to communicate with another SD-WAN vendor solution without the reliance on a common set of infrastructure or protocols within the SD-WAN itself. We'll talk a little bit about why we chose that approach as well. So the main reason was to basically begin the process of interworking between these devices in a more standard way, rather than an ad hoc way, in order to allow enterprise users to basically deal with M&As in situations where they have multi-vendor networks, maybe multi-vendor SD-WAN networks that they need to interconnect. So this is the slide there. Can you just go to the slides for the moment? There was one introductory slide. Can you put the slides for me? Just keep working out. Yeah. Okay. There was a slide here that I wanted to show just to give you sort of an introduction to ONUG, Open Network User Group. How many people are aware of ONUG? Okay. So ONUG is primarily a user group forum. It is not a standards body or a standards organization, creation organization as the IETF would be. One of the benefits of one of the benefits of ONUG, in my opinion, for reason for going is we do have a large community of users, a large community of customers who are building enterprise WAN networks. We get to see the architects from those customers come out and talk about where they want to take their networks in the next generation, both from control plane, WAN architecture, security, visibility, control perspective. Okay, and there it is, Jeff. The second slide there. Thank you. Yeah. So that's one of the key things that ONUG brings to the table, and why we started this process within ONUG to create this interworking was because of the demand of the user community itself, and they were the ones that basically started the initial sets of requirements that we needed, that they felt we needed to do that. Okay. Thank you.
Now you remember.
Is it working?
Mm-hmm.
Should have used my laptop. Are we almost there?
Almost there.
Okay. Sorry about this. So ONUC has two meetings a year, two what you would consider, major meetings a year, usually one on the East Coast and one on the West Coast. And we have a set of interim meetings for the OSC working group where we continue to work on requirements and specifications. So you can see here, the folks that actually come. We do get a lot of the Fortune 1000, Fortune 500 for sure, large enterprises, customers. I would say, from across the world, we get a number of large vendors as well there, and cloud providers are now coming in, Google, Microsoft, and those as well. Mainly driven by the access that we have to the user community and the visibility we get because of that as vendors. Okay, you want to hit me? Do you want to move me forward? Come on. Next one. Is this my bad that's causing this problem? Oh, you had it. You had it. Yes, select. So I want to give you a view of what we are working on and what we've done so far. So the picture you see here is not too far. Okay. The picture you see is our reference architecture. We spent a few meetings basically hammering out what an SD-WAN reference architecture would look like. And what you see here is sort of the user interface level at the top, the client orchestration layer, we call it. The idea is that is the place where you would create either workflows, GUIs, or tools, which would be used to then make API calls into the infrastructure to configure specific SD-WAN services. So one of the things we're trying to do with this interoperability working group that we have is to create and standardize service definitions within the SD-WAN, not protocol definitions, but service level definitions, and create models and APIs around those service level definitions that vendors can then go off and implement, so that they can create, when we make these common API calls, they will create a service that has a common behavioral characteristic between different SD-WAN vendors. Okay, so to that effect, you can see we're standardizing sets of APIs across the interface to both the SD-WAN manager, which is the management plane, functional entity, as well as the controller, which is the control plane functional entity, which may or may not be separate from the management entity. We've also got interfaces envisaged where SD-WAN managers and controllers could talk to each other. We don't have specifications of what that information that might cross there might be, but that's something we want to work on in the future as well. And then, of course, some of the interfaces that you see inside that gray box are proprietary interfaces. So the idea that everything's sort of inside that gray box is more of a proprietary interface. We are not looking to specify those specific reference points at all. But you can also see at the bottom that we've treated the SD-WAN network as a functional entity in and of itself. We've defined a number of network interfaces to allow us to connect to external domains, both cloud, extranet, other SD-WAN domains, which is a primary function of what we're doing, as well as other network domains external, which may not be extranet. So we're looking at making specifications in all these areas, as well as the SD-WAN client specification at some point as well, attachment point. All right. Yes, okay, good. So the other part of the puzzle, of course, is the actual interworking model that we want to look at in terms of how we want SD-WANs to interoperate. So we're taking a border-based approach or a gateway-based approach. The reason we're doing this is if we think of the SD-WAN as two different domains, each of which has different protocol control planes and data planes, and we confine the interworking to the border elements, the amount of feature set and specification that we have to do is obviously much less from a work perspective. So we're able to get some service level interoperability specifications out and APIs out quicker. Okay, and that gives us probably a better shot at interworking as well. If we want, we know that SD-WAN vendors do use standardized protocols, but they often make extensions to those protocols, and some of them are very extensive extensions. And therefore, trying to come up with standard data plane or control plane, at least in the first approach towards standardization, is something that we see happening in the future, but it's something we see also taking a long time. And certainly something that would be more the purview of the IETF, not necessarily the purview of a group like ONA, right? So we have these OSE gateway elements, and the purpose of those gateway elements is really to do the interworking between the SD-WAN domain and a standard NNI, which we are defining IPsec-based, BGP-based, between the gateways that all vendors could agree on and basically allow to have the ability to configure those gateways through their own controllers. And therefore, when you want to create an exchange service, you can make a single API call, a common API call to both vendors here, and you can be guaranteed to get the same kind of service created at the gateway edge for interworking. So that's the concept. Okay. All right, and just to give you a sense, a little bit of the sense of how we're looking at the network from a multi-domain perspective. Okay, we see, in a general model that we would have, again, this client orchestration there, which we are not really specifying, only specifying the API calls that would be that it could consume. We have potentially a number of SD-WAN serving areas. And then there are serving SD-WAN managers in each of those areas, which could be from one vendor or another, providing a common API northbound to the orchestration layer. So in the actual working group of the OSE that we have a number of different task forces that are doing work in different areas. So we have an authentication framework group that's looking at authentication of network elements between the domains. So most SD-WAN solutions have the concept of that authenticated network element that does a PKI or similar exchange to basically authenticate itself as a valid and element in the network. Okay, and then if you're trying to, of course, interwork between domains, you want to know that the elements you're talking to are also valid in that domain as well. So we're working on the procedures and the interworking specs for that. There is some work going on service chaining, how to extend service chains between the two domains, as well as reachability exchange, which is basically how are we connecting virtual networks or VRFs that are created in one domain to VRFs that are created in another domain. How are we stitching those together? And there's a couple of proposals on the table for how to do that. Some are controller to controller. One is controller to controller based. The other is BGP based. All right. OSE Hybrid Cloud API is a newer task force that we identified as something that is important. And the idea here is that we are seeing more and more customers wishing to instantiate SD-WAN edges at the edge of virtual private cloud. Many cloud vendors provide that service in their catalog. And then, of course, there's different APIs for all of those cloud providers, and we'd like to homologate that API and provide a standard API for doing that. All right. There's also some active specification work going on. The architecture spec is basically available first draft that you can look at and get a sense of how the reference SD-WAN architecture is put together along with the interface reference definition points. We have a path management spec, which basically provides a specification for the access network service definition. So access selection, how do I select which WAN access network to place traffic on based on policy, based on SLA and performance. And then we have the external gateway spec, or the OSE gateway spec, which is really focused on the cross-domain reachability and segmentation exchange between two SD-WAN domains. And then we have an API format spec where we're looking at what the API formats we will support are, as well as the service model specification.
You want to? It's not working. I'm doing it.
Are you? Okay. So you're watching my finger. One of the next slides, right? I thought I was good. Actually, go ahead for one more, because I think that, yeah. So what I wanted to show here was, all my hidden slides are getting shown, that's why. So I just want to give you an overview of sort of key progress and results of where we are in terms of our work. So the SD-WAN reference architecture, as I mentioned, the first draft of that spec is published and available for review. The OSP, the OSE Path Management Service API, we have actually a first draft of the API that's created in Yang. It's not really ready for implementation yet. We do need external review, people to help us improve that and make sure it's structured correctly. And then we have, of course, the gateway service, the OSE Gateway Service API, where we have, again, a first cut Yang modeling for that. So we need to go through a set of reviews and refinements of those models for segmentation, instant creation, and cross-connect, as well as IPsec definitions between that are needed on the interfaces as well. So these are all Yang-based service models that we're starting to create. And if you're interested to look at these things, you can go and look at them. I've got them on my GitHub, which I put the information there. You're welcome to join and basically link up and take a look at those and provide me with comments and anything like that. Okay, go ahead, one more. I forgot you're doing. Okay, go ahead, one more. So I just wanted to talk a little bit more about the hybrid cloud use cases, the very important use cases that our user groups have defined for us, right? So there are three major use cases. One is the SD-WAN edge inside of a virtual private cloud or infrastructure as a service, okay? That infrastructure as a service deploy could be a Microsoft Azure, an AWS kind of architecture where the customer is hosting a bunch of workloads there, but wants to bring that onto their SD-WAN network. So if it has access for its branches, a sort of a companion use case to that is the idea of doing the same thing in a carrier-neutral facility. Many enterprise customers are looking at using carrier-neutral facilities part of their WAN architecture as a confluence point for cloud, for high-speed interconnect to other places, extranet, and those like that and the like as well. So and then the third case is a public cloud or SaaS type use case where we're basically providing a specification of how to offload SaaS-based traffic directly at either a regional internet access point or at the branch itself, all right, via the internet or MPLS providers. Okay, so those are the three major use cases we're looking at in the hybrid cloud. If you want to go ahead, Jeff, one more. We have a number of work areas here that that we want to work on, and there's a lot to do. Actually, go to the next one. Oh, okay, that's fine. It just formatted differently. The slide looks different to me than what I have in my PowerPoint. I'll just go back one. I thought I had to. Is it going to go through? I guess that slide was basically just highlighting that there's a number of work areas within the hybrid cloud use cases that have to be looked at. Okay, so we have to basically, if we're going to come up with a homologated set of APIs that that potentially, it's the third one from the end there, Jeff. Just up from that could be adopted or might be adopted by virtual private cloud vendors, and we need to take a look at, I think step one was establish the use cases and requirements. We talked about that, and I showed you the basic use cases we've defined, but there's a lot of work in terms of developing a translation or an adaptation API, much of which involves kind of understanding, how the SD-WAN devices, virtual devices, virtual network functions would be spooled up within these CSPs, looking for common ground and then trying to homologate those APIs into a common either translation layer API that could be used and implemented within a vendor controller or something like that. So we have, we want to find a common set of services, try to homologate those services as well, and then basically have an API that allows you to establish a VPC connectivity to the SD-WAN from the cloud vendor. So that's what we're headed for, and that's kind of a sense of what we're doing in ONUG. Maybe now the time is open up for discussion, but you may wonder sort of why I'm here and why we're doing this. Hopefully that this information is of some use to you to understand what's going on in SD-WAN a little bit more and to understand work areas that need to be looked at from a interworking and standardization perspective. From an ONA perspective, we're not really a standards body per se, and we knew that going in when we started to do this work. There's no desire for us really, I think, in the ONA group to really become another standards organization. Doesn't make sense for the industry probably either. But what we have done is establish a number of use cases and reference architectures. And we, from our perspective, wanted to come here to talk to this group, at least to begin starting to this group, to talk about whether there's interest within this group in basically helping us to create the drafts to specify the different services, the different service level behaviors, and interoperability APIs that we need, and also to really define the Yang models underlying those as well. So that's why we're reaching out. We wondered if we wanted to see if there was, some interest in taking up this work within this working group or within other working groups, and if there was interested parties willing to contribute. So for that, I think we'll open up for discussion. Any questions or comments on that?
Well, thank you, Steve. And so I'll kick off. I think it would make sense to do a top-down approach and use definitions in 8302, Adrian, starting with service definition, where we could define service in vendor-independent manner, just pretty much taking intent and passing it down to elements that might not necessarily interwork with each other. However, the translation should be done outside of intent scope. So again, I think it's pretty good described in 8302 how service model interacts with network model, interacts with device configuration. And I think know-how is here in IETF and routing working group, in netconf, netmod areas. So this is where I see personally, not as working group chair, but as ONOC member and IETF member, where we could potentially start helping ONOC.
Adrian Farrell, 8309. Oh.
Let me maybe ask another question then to you guys. Maybe the wrong way to ask it is who wants to do work, right? Because the answer may be no. But if we were to bring RFCs and drafts in this area, is this something that the IETF would be interested in seeing, this working group in specifically? I feel like it's a routing area kind of work that we're doing. And would it be amenable? Would you guys want to participate in refinement of those drafts? Would you guys be happy to listen at your meetings and provide us the feedback? Maybe that's a better question to ask.
Jeff, I think a bit of what you're seeing is not so much lack of interest. It's more that IETF as a whole has generally avoided intentionally doing API work. And we tend to focus more on protocols. We tend to focus more on the mechanisms that the APIs would instantiate. And the Yang stuff that we've done recently certainly has pushed us more in that. Some of our service abstraction models sort of push us in this general direction. But this has not been traditionally the best fit for IETF type stuff.
I understand. That makes a lot of sense. I'm thinking we will get to a point in the evolution of this that we will need that kind of work to be done. I just don't feel like we're there yet. But in the meantime, it seems like there's demand for this type of service.
So the kind of amount of people who represent SD-WAN vendors as such is definitely underrepresented in IETF. We've got a few vendors here, but definitely not all of them. And potentially, we should get more people involved, but I would really like to start the work. And I would appreciate people standing up and, if not committing to work, at least expressing their ideas about what and how.
Ben Hendricks from Nokia, as an SD-WAN vendor. I think I like the idea of starting with this work because there is an industry gap, I think, and given the expertise of Yang and all the modeling which has happened in IETF, I do agree with Jeff that traditionally it's not the expertise of the IETF historically, but I think
over the last couple of years, we have been progressing with Auto-SN, L3SN, and stuff like that. So there is definitely expertise, and there is a gap in terms of all the application-aware routing and stuff like that. So there is definitely some holes there, which I think would be good to define somehow, so that we at least have, from an orchestration point of view, the ability to have a single data model which represents the SD-WAN service, and as a result have some support for interoperability in terms of that aspect. And assume that the standardized interface between the two SD-WAN solutions would be like a BGP or a standard model A or something like that. That could be a good starting point to start some work here.
Yeah, I agree. There's a number of technologies already on the books here that could be brought to bear for protocol and data plane level standardization in the future. SD-WAN is primarily an overlay technology, and you may be aware that MEF is doing work as well in this area. We don't disagree with what the MEF is doing, but the user community in ONUG is more interested in transport independence. We want to keep the overlay and the underlay decoupled as much as possible. So there are other approaches to SD-WAN, which is more about orchestrating underlay circuits. And we want, there's definitely a group in the market that wants to keep it as a pure overlay.
And I think there's also an opportunity to learn what people actually do want. I see Ignas here, and we've brought a number of times the issue of decoupling of what consumers of technology actually want versus what we are doing here. So working with our community gives ability to take requirements of people who are actually consuming technology and want to do it in a particular way.
Lou Berger, I think it would be really interesting to hear feedback on some of the models that we've done, like the service models have been mentioned already, to take a look at those and say, hey, you're missing things here. And I think drafts on that would be really interesting, either identifying shortcomings or even proposing augmentations to fill the gap. And you may find that when you start doing those augmentations, we actually have a model somewhere else that'll compare, or that we actually have a gap that can be filled. So I think that'd be really interesting.
Yeah, cool. That makes sense. And maybe Jeff, you can tell me where those models are, and we'll start looking at that as well.
So Ignas is our director for operations, and this is where Jan lives.
So Ignas Bogdanas, just a comment about the potential venue for this work. IETF is good at working at fragments of the technology, at the components, not necessarily at working on the end-to-end systems. Therefore, probably the practical way forward is that IETF has control on the components, young language as such, methodology of the modeling, technology-specific models. Working on the modeling above that, what IETF calls service models, probably is not the area of the main expertise of IETF. And the working interaction might be that the service model aspects are developed on our ONUG side, in whatever way that works. And the necessary hooks and consultation happens with the relevant working groups in IETF.
Yeah, no, I see your point as well with the gentleman earlier as well. I guess the question is, especially around APIs and end-to-end, is this an area that you think IETF should grow into, or kind of stay in its current mode? There's enough work to do, don't get me wrong.
There's probably enough work to be done. The question is there an expertise to work on that?
Okay.
And I believe expertise is here, so we might disagree on this point. Someone has to do the work. You've seen many frameworks developed by ETSI to some degree by MEF, where there is outside description of what it is, but it's completely empty inside. There's nothing you can implement.
And that's exactly the problem. The specifications are developed, which look nice on paper. They get numbers signed. Do the actual users have value of that? Do they care about that? Is this something practical that can be used?
And I think this is the point we are trying to address, to make something that's useful on top of requirements coming from user groups and continuous loop of validation based on what we are doing here.
I think the other thing to consider too is that the user base, at least in the enterprise side, and generally even service providers are looking to push in this direction, is I guess less amenable now to building their use cases out of the components that are provided. They want the components to be put together for them. And so from that perspective, the trend in the user community for consumption of technology has moved from components to more use cases. So this question of if you don't have the expertise here, or maybe I think you do, I'm sure there's enough smart enough minds in the room to basically make that leap. If that's something that you could see as part of the evolution. This feels to me, what we're trying to feel is very much like an MEF type of engagement. I originally modeled the working group after MEF approach. MEF is not 802.3, right? And it's not 802.1. It takes technology from 802.3 to 802.1 and it puts it together to accomplish standard use cases for the network. We're kind of doing the same thing. But we don't have a body to do that in the industry. MEF is doing that for SD-WAN, but not doing it the way that I described earlier, which is more focused on the overlay networking. So we're kind of in that. We need to create, I think, a body that does this.
And there's another point to it. So outside of strict overlay solution, we see drafts that are trying to describe how overlay interacts with underlay. So segment routing related drafts and SD-WAN plus segment routing. So there's some work that's already happening and defining the interfaces of how this interaction is happening. It might happen here as well, since we own the underlay technologies anyway.
Next, quickly, could we work with ONOG in a way that we could help us to say these are the focus points? Because that would be very beneficial, I think.
I think so. And my initial thought process on that is, ONOG has the ability to bring, the use cases and requirements in, right? And has the enterprise base there to basically help to drive that direction, right? There's, in the enterprise user community, they're creating RFPs and RFQs, sort of generic ones that, they're trying to use to drive the vendors, right? We can take that information, this is what we've done here, and to some extent, and basically start to translate that into, into actual workable interworking specifications. So I was thinking that the requirement stuff comes in, people here see that, they start working on it and bringing drafts in, right? And this is the place to really make those drafts, give those draft teeth, right?
Would be, I think, a perfect model to go forward with it.
Since this is Linda Dunbar, I also go to ONOG, and I definitely think that lots of work can be done by IETF, even though IETF may not do the API per se, but like, for example, SD-WAN exchange, right? So when we talk about overlay deployment, and you could have pocket of device here belong to one vendor and pocket of device here belong to another set of vendors. And how do we distribute the control information, like even the peer authentication, even the some of the IPsec configuration, and some of the tunnel encapsulation, like extended tunnel encapsulation, the BGP, which I just talked about. So I see IETF can do lots of protocol extension to fill the gaps to what ONOG want to do. That's why I think it's worthwhile to have a focus group to discuss that. ONOG has use cases, and we have people to identify the gaps. Of course, we have to do lots of homework. It's not like, because the user's use case and requirements are very big and grand, and there are vendors who deploy SD-WAN, and they find some issues with existing approach, and then we put this together, and then IETF fill in the gap, and I think that would be very good for the industry.
I guess I could summarize my comment, this is Lou Berger, I can summarize my comments as me too. I think what you're proposing is a great idea. More than that, I think we would really benefit from it here. We'll benefit from it in the solutions we develop. For example, had we had a better understanding of use cases, we may have made a different decision in deprecating that mechanisms that Linda now wants to reintroduce. Or we may make different decisions at the lowest layer, and at the, for example, the service model layer, we may decide, or level, we may decide that we're missing things. So I think we really need that type of information here. I really encourage it. I mean, all I can encourage it is personally, I can't speak for the organization or any working group, but I think it would be a great thing to see come in here. Thank you.
Okay, great, thanks. All right.
So,
What do you think the next steps are, Jeff?
so next steps, I'm going to pull the working group on email and try to see whether we could reach a stage where we could form a design type entity where requirements from ONOP and other user-driven organization could be reviewed and we could start working upon. Obviously, if there's no interest, I'm in no way in charge to enforce this work. However, if we find that there's enough people who are interested or willing to contribute, I think it would be of value for larger community. It would be of value for SD1 members, perhaps longer term, but eventually people who can talk to other people win over people who cannot. So that's my point.
So I think, if there are folks interested at least to learn more, you're welcome to join the OSE. So you can go to the ONOP website. There is a form to fill out there to indicate your interest. We try to meet via teleconference every 2 weeks, and we have a face-to-face meeting coming up in September. If anybody's interested, you can contact me, and I'll get you hooked up with the right information. So if you're interested to come and see what's going on, you have an interest in learning and doing more.
So the initial data models are on GitHub, and you've seen on the slides where to find. There's also a number of C documents you could read and see what has been done by girls. So you've got points to start with. We've got Slack channel, and so welcome to the one community, I would say.
Thanks very much.
Thanks. Any more questions? See you in Bangkok.